Hello guys, welcome back to this amazing lesson. In the previous lesson, we look at some SQL basics, the select, the where clause and all that by using it to solve some questions. In this lesson, we'll be looking at the what? The join. In real business databases, data is stored in different tables. For instance, our superstore data set and database now that we have here. We actually have the the customers table, the product table, and the other others table. This customers table actually comprises of the customers details such as name, region and segment, while the product has product details such as name and category. For the others now, it actually has transaction, but only references the customer underscore ID and the product underscore ID. As a data engineer now, your job is to join these tables together so analysts and business teams can see a complete picture, like which customer bought which product in which region and how much profit they actually made on it now. Now, before we proceed, what is a join? A join combines rows from two or more tables based on related column between them, called a A foreign key relationship. We have types of join now. We have the inner join that actually return only matching rows, while the left join actually returns all rows from the left table along with matching rows from the right table. For the right join now, all rows from right along with matching from left, while the full outer join now, it actually consider everything from both sides. Now, the most used ones are the inner join and the left join. Now let's solve this question now. We'll be using the inner join. This question says show each customer's name with their order ID and product category. Now let's actually solve this now. To solve this now, I'll bring out my select. Where am I selecting? From the orders table, I want to bring out the order underscore ID. Order underscore ID, comma. From the customers table, I want to bring out the customer name. Customer underscore name. Now, comma. For the product now, I want to bring out the category. Category. And from the sales now, from the order or again, I want to bring out the sales. Now I will now say from where now? From orders. Now give it an alias of O. Now inner, I'll use the inner join. Now what am I joining now? The customers. I've actually make use of three tables like that, so I'll give it an alias of C. Now on. From the orders now, I'll bring out the customer underscore ID. That's what they actually have in common. Customer underscore ID. Now equals the customer underscore ID. Now the next one, I'll use the inner again to join the other table. Inner join. Now this time around, I'm joining the product. I'll give it an alias of P on that's order dot product underscore ID equals. So I'll bring out the I'll bring out the product underscore ID again. Now I'll put a semicolon here. I'll highlight everything we have here now. I'll run this now. You can see it now. Everything works perfectly well. So this actually combines the orders along with the customer and the product table. You can see now from the orders table we get the sales. From the customers table we get the we get the customer's name, and from the product table we get the what, the category. So you can see it now. So this is everything about it. So this is actually what powerful for what relational database. Now let's see another example now. Now let's solve this second question. Now this second question says find total sales by region, including what customers who have no orders yet. So we've actually seen an example under the what inner join, but this time around we'll be saying what, we'll be making use of our what left join. Now I'll now select, where am I selecting, sorry, I will select from the customers table. I'll bring out the region. Now I want to sum open parenthesis where I want to sum from the orders table. Now I want to sum the sales. Now I'll now give it an alias of what, alias of total underscore sales. Now I'll from where, from customers table. Now I will now make use of the left join. Now left join orders, which is what I'll give it an alias of O. Now what they have in common on for the word customer, now I'll bring out the word customer underscore ID. That's what they have in common. Equals what, equals order dot what, customer underscore ID. Now I'll now hit on enter. I'll group this by customer region. I'll put a semicolon here. I'll highlight everything. Now I'll run this. Now you can see it. Now the question says find total sales by region, including customers who have no order yet. So we've actually what done that now using our what left join. Now the reason why we use the what the left join, now we want all customers even though without what orders now. So that's one of the reasons why we use the left join. And orders table might not what have all what have a record for some customers, but still what include it in their region. So in the case that we have that kind of what, that kind of data, so it will actually what include it in the region. This left join is actually what very useful in what, in business, because sometimes now in an organization, maybe the management want to see not only what sales made, but also what the region kind of, let's say the region where the customers or sales are actually what are actually missing. So it will actually what fetch it out for us. Now let's solve this question. Now this question says what, list all products and show the total sales even if some products have never been what, have never been sold. Now what this question is actually talking about is what is the product purchased and what, and the product that is what not purchased. That means the purchased versus the non-purchased what product. We'll be using the what the right join to solve this question now. Now I'll select, what am I selecting from the what product table. I'll bring out the what product underscore name comma. Now I will sum. How am I summing this time around? I want to sum the what order. I'll bring out the sales from this orders table. I'll give it an alias of what total sales, total underscore sales. Now I'll hit on enter. From orders, I'll give it an alias of O. I'll write join what product product, I'll give it an alias of P on what they have in common from the products table now. Sorry, from the others table, I'll bring out the product underscore ID. Now equals what? Product dot what? Product underscore ID. Product underscore ID. I want to make use of the group by. The group by the what? The product. From the products table now, I want to bring out the product name. Product underscore name. Now put a semicolon. I will now select everything here now. I'll run this. You can see it now. Product underscore name, total underscore sales. So in this case now, every product will appear, even those with with no sales. You can see it now. This product now, chair underscore 8, has has no sales. So you can see it. That's where we have none here. So if I scroll down, you can see some are null, some has values. So that's how to make use of the right join. Now let's solve this question. This question says show all customers and all orders, even if a customer has no order or order is missing is missing a customer link. Now we'll be making use of the full outer join to solve this question. Now to solve this question, what this question is actually talking about now is that all customers and all the orders. Now let's solve this now. To solve this now, I will now come here. I will select. Sorry, let me bring this down and let me just comment it. Okay. Now I will now select. What am I selecting? From the customers table, I want to bring out the customer name. Customer underscore name. Now I'll put a comma. From the others table, I want to bring out the order underscore name. From the others table, from the others table, I want to bring out the order underscore ID. So from the others table again, I want to bring out the sales. I will now hit on enter. So I want to use customers. Customers table. I'll give it an alias of C. I'll now make use of my full outer join now. Full outer join. What am I joining? The orders. Now on the customers table, that's customer underscore ID. Now equals what they have in common? That's orders, customer underscore ID. I'll put a semicolon. That's what they have in column. Sorry, that's what they have in common. So I will select everything now and I'll run this. You can see it now. This is the customer's name. This is the order underscore ID, and this is their This is their sales. So what we actually did here down is that let me scroll down now. You can see everything now. Some are null and some has value. So what we actually did is that some customers without order actually appeared, and others without a valid customers also appears, which is actually a bad data. You can see it now. So in this lesson now, we've actually looked at the join which actually connect our relational tables together. So from the inner join, the left join, the right join, and the full outer join. So in a real world of data engineering, the inner and the left are the most used joins. The right and the full ones are less common, but we will actually need them when we are ensuring no data is what left behind during our what analysis. That will be all for this lesson. See you in the next lesson. Bye for now.